Hey guys, this is Mr. Nocello. I'm going to be filling in for a day. We're going to be doing learning more about some proofs and how we can use what's called the addition and subtraction postulate. So first off, we'll look at the addition postulate. And the addition postulate says that if equal quantities are added to equal quantities, their sums are equal. And that should make sense because if I said 2 plus 3, does that equal 2 plus 3? So if equal quantities are added together, then what they add to will also be equal. So 2 plus 3 equals 2 plus 3. Well, yeah, of course. So in a proof here, it says given that AB is congruent to DE and that BC is congruent to EC, they want us to prove that AC is congruent to DC. So they're looking for us to show that the whole left side is congruent to the whole right side. Now, remember, AB is congruent to ED because it was told to us, and CB is congruent to CE because it was told to us. So therefore, if the two parts are the same, then a blue part plus a pink part should equal a blue part plus a pink part. Same thing if there were numbers there. If this said 4 and 2, and this said 4, and this was 2 therefore, then the whole side would be 6, the whole side would be 6. But recall, in a proof we don't use numbers, we're just using statements of congruency. So how do we write this in a proof? So remember, as with all statement, reason proofs, we're going to start off statement, reason. Step 1, you're going to restate your given, that AB is congruent to DE, and that BC is congruent to EC. That's told to us, that's given information. And then we can say, well, if you take AB and you add BC, then that's going to be congruent to if you take DE and you add CE. Which means, and how do we know this is true? Well, AB and DE are the same. And we also know that BC and EC are the same. So if you add equal numbers together, then the whole parts will equal together. Well, AB plus BC makes AC. And DE plus CE will make DC. And we can write, we know this by, it's called the addition postulate, but just writing addition is enough. And that's it, because now we have stated what they want us to prove. So, one other way to use the addition postulate, here it is. Given that AB is congruent to CD, they want us to show, they want us to prove that AC is congruent to BD. So in order to do that, we should notice that if this AB and CD are congruent, well, look at BC in the middle. BC is part of, well, here's BD, here's AC, so you can see there's some overlap here. So that is, by the reflexive postulate, we could say BC is congruent to itself. Let me use a different color there. So now if you add AB plus BC and you add DC plus BC, if the parts are equal, then the whole is equal. So the only difference here is we have to include the reflexive postulate. So this is an example of sometimes you're not given all the information in order to use addition. So step 1, AB is congruent to CD, given. Step 2, I'm going to say that BC is congruent to BC. It's called the reflexive postulate, reflexive. And then step 3, if you add equal parts to equal parts, then what they part together will also be equal. Right? Where did the equal parts come from? AB and CD are the same. BC is obviously the same as BC. So pink plus blue will equal pink plus blue. Therefore, the wholes will be equal. Now, subtraction works very similar, except in this case, subtraction is, let's see, used if you take equal quantities and subtract them, their differences are equal. Well, yeah, of course, 7 minus 4 Does that equal 7 minus 4? Yeah, 3 equals 3. So if you take equal numbers and subtract equal numbers, then what you get, your difference, will also be equal. So in this picture here, it says that AC is congruent to DC, and it tells us that BC, the little part up top, is congruent to CE, the little part up top. And we want to show that, we're trying to prove that AB and ED are the same. Step 1, restate the given. And then step 2, if you take AC and you subtract BC, since it will be congruent to if you take CD and you subtract CE. Which means, what are you left with when you take the whole side AC and you cut out BC? You're left with AB. And on the other side, if you take the whole side CD and you cut out CE, you're left with, I'm going to write it as what they said, DE. And this is called subtraction. How do we know this is true? Well, AC and DC are the same. BC and EC are the same. So if you take equal parts and you take away the same equal parts, then what you're left with will also be equal. Subtraction postulate. Similar to up top, AC congruent to BD. And that's all they tell us, but they want us to prove that A, B, and CD are the same. So if I cut out BC from the equal parts, what I'm left with will be equal. Statement, reason. So step 1, restate the given. Step 2, we're using the reflexive BC. And then step 3, if you take AC and you subtract BC, it will be congruent to if you take BD and you subtract BC, which means what are we left with? We're left with AB on this side, and if you take BD and you cut out BC, you're left with CD on this side, which is great because that is what we wanted to prove, and we know this by subtraction. So what I'll do, guys, is I'm going to post this video. Obviously, you could follow along in the lesson. What I want you guys to do is try the proof on the next page. It might be a little difficult the first time you use addition or subtraction. Really, I find it takes a few problems for students to recognize the difference between when to use addition and when to use subtraction. But what I'll do is I'll post a full key of this problem also in the classroom. Okay, guys, thank you so much for letting me teach you guys a little bit, and have a wonderful day.